I want to reiterate that this strategy is an alternative to using the zeros, the y-intercept, and the denominator for the restriction. This is an alternative to that, and it is putting it into the transformation form. So we'll do, again, the transformation form. To do that, we're going to divide these two expressions. So x minus 1 into negative 2x minus 3. Dividing this in, it's going to go in negative 2 times, so negative 2 times x gives me negative 2x plus 2. Subtract those cancel out. I end up with a remainder of negative 5. So what that means then is, if I were to write this in the transformed form, my remainder goes up top over my divisor, x minus 1. I should make that into green. So the negative 5 represents my expansion, and then the minus 2 represents my quotient, so it becomes minus 2. So negative 2 plus the remainder over divisor, and that represents an equivalent expression to the one above. So this is an equivalent expression for f of x. And with this expression, I can see I have a horizontal shift of plus 1. So that's going to give me my vertical asymptote at x equals 1. I can see that I have a vertical shift of minus 2. So that means my horizontal asymptote is going to be here. So I have vertical asymptote at positive 1, horizontal asymptote at negative 2. My expansion factor is going to help me get my coordinates. So if I want, I can go 1 over 5 down, 1 over 5 up. Okay, to get that point, I'm going to use a table of values and transform the table of values. Okay, this is maybe unnecessary, but it is consistent with what we've done before. So using this the transformed set of values, I'm going to do plus 1, plus 1. This is going to be times by negative 5 minus 2, so it's going to be positive 5 minus 2, so positive 3. That's going to be times by negative 5 minus 2, so that's going to end up being at negative 7. So this has been vertically flipped. Okay, so I'm going to get graphs not in these quadrants, but I'm going to get graphs in these quadrants here. Okay, so then if I graph this, I'm going to end up with a graph. If I plot these two coordinates, 0, 3, 2 over negative 7, so 4, 5, 6, 7. Okay, so that shows my expansion of 5 this way. Okay, and it shows me expansion of 5 in the other direction, minus 2. So, oops. Let's see here. So that's going to be 3, sorry, 0, 3. So that points right up there. So then I can draw my graph in through those coordinates. Okay, so again, I lose the detail of my 0 in that part of the graph. And really, it actually is probably more realistically, it's kind of going more down like this. And if I want to add that detail, I can easily find my 0. I can solve for the numerator equal to 0, and I end up with positive, so it's going to be negative 3 over 2, so it's going to be right about there. So my graph, if I want some more detail on this, I can put that extra point in there, and I can have more detail. Again, so these are slightly different, they give you slightly different information, but allows you to draw the graph. So this is an alternative way to draw that same graph. One thing to note is that when I have a negative remainder, we end up going across this negative diagonal. If I have a positive remainder, I usually end up across this diagonal. So notice that this one here had a negative remainder, so we ended up across this diagonal. This other one had a positive remainder, and it ends up across this diagonal. So that's a plus 7, so it ends up across this positive diagonal here. So that has positive slope. This is positive slope. This is negative slope. So we consider those. We can relate the diagonals, the negative and positive diagonals, to those slopes.